how will we solve this? Through separation of variables. So psi is this. Okay. Okay. Now let me write the equation again. Del 2 psi by del x2 plus del 2 psi by del y2 plus del 2 psi by del z2 plus 2me by h cut square into psi is equal to 0. And what is psi? Psi x y z is equal to capital X small x into capital Y small y into capital Z small z. I am just writing this. That is the V is like that, so you can write psi as basically the product of functions. One function is a function of x, another one is a function of y, and another one is a function of z. So instead of psi 1, I am just writing capital X. Just capital X is a function, nothing else. Okay. Achha, so what will you do now? Okay, so here del 2 psi by del x2, what will be that? Del 2 psi by del x2 will be capital Y into capital Z into del 2 x by del x2. Okay, then del 2 psi by del y2, what will be that? That will be capital X into capital Z del 2 capital Y by del y2. Similarly, del 2 psi by del z2, what will be that? Capital X into capital Y del 2 capital Z by del z2. Okay, this thing. Okay, now and this will be I mean 2me by h cut square into psi. Okay, Ajay. So using this this is the equation number 1 only that I had given equation as using this and dividing both sides of 1, dividing 1 by xyz. Okay, dividing both sides of 1 by x, y and z. What do we get? We get here, okay, x, y and z, we get 1 by x del 2x by del x2 plus 1 by y del 2y by del y2 plus 1 by z del 2z by del z2 plus 2me by h cut square into psi. By we are dividing by xyz, right? Now what is psi? Psi here is basically this thing only, xyz only. So dividing basically by psi only we are doing. So here dividing by psi, so the psi has gone, so this is equal to 0. Okay, now you see that here let this be equation number 2. Okay, so each term of equation 2, okay, each term of the equation 2 depends, each term of equation 2 depends on a different variable. Okay, that is, this one depends only on x, this one depends only on y, this one depends only on z, and this is a constant. Okay. Okay, and the three variables and the three variables are independent of each other. Three variables are independent of each other. Okay. And the last term of equation 2 is a constant. Last term of equation 2 is a constant. Okay, each term here is dependent on only a single variable. This is dependent on x, this is on y, this is on z, and each are independent of each other. This is independent of this is independent of this, and this is a constant. This can only be possible, this can only be possible, okay. uh, okay, when each of them are individually constant, when each of them are individually constant, when each of them are individually constant, okay. This can only be possible when each of them are individually constant. So I mean, suppose say for example, is this kind of equation x square plus y square plus z square plus 25 is equal to 0. When can this be possible? This will be a constant. Say suppose minus 9, this is also minus 9, this is say minus 7 plus 25. See, it becomes 0. Okay, so when each of them are equal to some constant, so let they be constant. So 1 by x del 2x by del x2 is equal to say minus alpha square. 1 by 1 by y del 2y by del y2 is equal to minus beta square, and 1 by z del 2z by del z2 is equal to minus gamma square. Okay, so from here what do you get? Del 2x by del x2 plus alpha square into x is equal to 0. Okay, then here del 2y by del y2 plus beta square y is equal to 0, del 2z by del z2 plus gamma square into z is equal to 0. Okay, so here what will you do now? Here so ultimately what comes actually? So if you do this, if you put it in this equation, okay, if you put it in this equation, this is minus alpha square, so minus alpha square, see here, minus beta square minus gamma square, minus alpha square minus beta square minus gamma square plus 2me by h cut square will be equal to 0. Okay, so from here you can find out E. Therefore E, that is energy eigenvalue, E will be h cut square by 2m into alpha square plus beta square plus gamma square. Okay, this will be the equation. Acha, now what will be the solution of this? Solution. What will be the solution? X, again the same equation as that in the different Schrodinger equation I've done earlier today in the beginning I told. So what will be the solution? X will be equal to again a1 into sine of alpha x plus e1 into cos of alpha x. Similarly from here capital Y will be equal to a2 sine of beta y plus b2 cos of beta y. Then z will be a3 sine of gamma z plus b3 cos of gamma z. Okay, okay, so this is the solution. So now nothing, just you have to apply the boundary conditions. So applying the boundary conditions, what are the boundary conditions? Applying boundary conditions. Okay. Applying boundary conditions, psi of uh, this 0 y z is equal to psi of x 0 z is equal to psi of x y 0 will be equal to 0. Okay, so from that it means basically x you are putting 0. From that what will you get? Psi of this is equal to 0. That means there the wave function becomes 0. That is psi at x is equal to 0. Definitely the wave function will become 0. Okay, so therefore x will be 0. So what will you get? And here x is 0. So from there we get what? b1 will be equal to b2 is equal to b3 will be equal to 0. Okay, so what will be the solution then ultimately? So this psi will be equal to psi xyz was what? A capital X into capital Y into capital Z. So what will be that? That will be this ultimately the solution will be what here? A1 into sine. Acha, let me do it in details for you, because many of you cannot understand. b1 is equal to b2 is equal to b3 is equal to 0. So from here what do you get? So if you say b1 is equal to 0, so what do you get here? X is equal to a1 into sine of alpha x. Okay, you take care of the see for this condition psi is equal to x is equal to 0, y is equal to z. So x is equal to 0 means what? X is equal to 0 means here here x is equal to 0. One sine 0 is 0 here. For x is equal to 0, this is 0 plus b1 x is equal to 0, so cos 1 here. So now at x is equal to 0, at x is equal to 0, capital X will be 0. At x is equal to 0, capital X, see here, at x is equal to 0, what do you have? You see, at x is equal to 0, psi is becoming 0. So that is why psi, so you have taken as psi 1x, psi 2y, so definitely psi 1x will also be 0. So at x is equal to 0, so 0 will be equal to, this is the 0 only, so b1, so b1 is 0. That is why from here b1 is 0. Similarly we can prove b2 is 0, b3 is 0. So therefore x is a1 sine alpha x. Okay, so from here what will you get? From here you will get this psi will be equal to what? Psi will be x into y into z. So x is what? X is here what is x coming? b1 is 0, therefore x will be what? a1 into sine of alpha x. Okay, similarly y will be what? a2 sine of beta y. Z will be a3 sine of gamma z. So this will be, x will be equal to a1 sine of alpha a, sorry, this will be a1, acha, a1 sine of alpha x into a2 sine of alpha y into a3 sine of alpha z. So this will be a1 into a2 into a3. So let us write it as a sine of alpha x into sine of alpha y into sine of alpha z, where a is equal to a1 a2 a3. Okay, a1 a2 a3. So now applying another boundary condition, here we had applied for x is equal to 0, y is equal to 0, z is equal to 0, psi is 0. Now at x is equal to a, y is equal to b, z is equal to c, then also it becomes 0. So what is the condition? Psi of uh, a y z is equal to psi of x b z is equal to psi of x y c, that is equal to 0. Okay, so from here what do you get? From here you get that uh, sine of alpha into a, this will be equal to 0. So this will be equal to sine of nx into pi. So from here what do you get? Alpha is equal to nx into pi by a. Similarly you get sine of beta into b is equal to 0 is equal to sine of ny pi. So beta will be equal to ny pi by b. So similarly sine of gamma c will be equal to 0 is equal to sine of nz into pi. So therefore gamma will be equal to nz into pi by c. Okay, nz into pi by c. So you get it now. So therefore psi will be what? Psi will be equal to psi will be equal to a into sine of alpha. Alpha is what? Nx pi by a into x sine of beta ny pi by b into y into sine of nz pi by c into z. Okay. So again now this function is unnormalized. Okay, this function is an unnormalized wave function, so you have to normalize it. How will you normalize it? You have to apply the entire boundary condition. That is not boundary condition, the normalization condition. Okay, so now to find the value of a, we'll use the normalization condition. We'll use the normalization condition. What is the normalization condition? Over the entire space, over the entire space, chi square into dv or d tau. D tau, I was in the morning I was telling d tau or dv is equal to 1. Okay, now entire space means what? From minus infinity to plus infinity. Now again, so the minus infinity to plus infinity, it is the particle is not present. The particle is only present between x is equal to 0 to a, y is equal to 0 to b, and z is equal to 0 to c. So that will be the basically the integration limit. So x is equal to 0 to a, y is equal to 0 to b, z is equal to 0 to c, sine square nx pi x by a into sine square ny pi y by b into sine square nz pi z by c into dx dv. What will be dv? Dx dy into dz, this will be equal to 1. So if you just simply do that, I am skipping some lines. So a square, it will be this integration of this one will be a by 2, integration of this will be b by 2, integration of this will be c by 2 will be equal to 1. So a will be what? A will be equal to square root of a by a8 by abc. So from here you can write psi of x y z will be what? Square root of 8 by abc into sine of nx pi x by a into sine of ny pi y by b into sine of nz pi z by c. Okay, this is the ultimately the wave function. Okay, here what are these nx, ny in the here? Nx, ny, nz are called here, nx, ny, nz are called as quantum numbers, and for different sets of quantum numbers, okay, we get different uh, states of wave function, uh, different sets of wave functions. So different sets and different states of wave function. That is the ground state, first excited state. Okay, you will understand it now. Okay, how will you do that? See here, E is equal to what? E is equal to. Achha, let me do it in the next page. Okay, so E will be what? E is h cut square by 2m. Okay, h cut square by 2m into alpha square plus beta square plus gamma square. Okay, so this will be what? This will be h cut square by 2m into pi square will come here, and this alpha square will be nx square by a square plus ny square by b square plus nz square by c square. Okay, so uh, how you can write this? You can just I mean h cut is h by pi. Okay, so sorry, h cut is h by 2 pi. So if you do that, it will come out as h square by 8m into nx square by a square plus ny square by b square plus nz square by c square. Okay, so the ground state, what will be the ground state? Ground state will be nx will be equal to 1, ny is equal to 1, nz is equal to 1. In the potential well, one-dimensional potential well, what was the ground state? Here, there you didn't have nx, ny, nz, you had only n. And for ground state, n was equal to 1. So here for the ground state, nx will be 1, ny 1, nz 1. So E111 it will be equal to h square by 8m into 1 by a square plus 1 by b square plus 1 by c square. Okay, this will be the thing. Okay, now suppose if we consider a cubical box, for cubical box, what do you have? A is equal to b is equal to c. Okay, so in that case, E of this nx, ny, nz, how will it change? That will be h square by 8 m a square, all will be the same, into nx square plus ny square plus nz square. Okay, now it is very interesting. Now for different sets of nx, ny and nz, n can have different values. Here only for the ground state you had 1 1 1. For the excited state it can have different values. We can have same value of energy. Now for different sets of nx, ny and nz, we can have different sets of energy. Then This is called as degeneracy. This is called as degeneracy. This is called as degeneracy. Okay. These states having different quantum number but same amount of energy are called as degenerate state. So these states having different quantum numbers, but same value of energy, different quantum number, same value of energy, are called as degenerate states. Degenerate states are called as degenerate states. Okay. So for example, let us take for example the first excited state. The first excited state. Okay. First excited state. Okay. Ajay, first excited state. How can this be possible? First excited in the in one-dimensional potential. What was the first excited state? N is equal to 2. Here you see there can be many states for the nx is equal to 2, ny is equal to 1, nz is equal to 1. Okay, a wave function is, this wave function will be what? Psi 211, and then nx is equal to 1, ny is equal to 2, and nz is equal to 1. What is the wave function? Psi 121. Okay, then nx is equal to 1, ny is equal to 1, and nz is equal to 2. What will be the wave function? Psi 112. Okay, for all these things the energy will be the same. All three have same energy. You see, what is the value of energy? All three have same energy. E that is E 211 is equal to E121 is equal to E112. All will have the same energy. What will be the energy? H square by 8ma square into, that will be say that what nx square plus ny square plus nz square. Okay, so this will be what? 2 square plus 1 plus 1. So 4 plus 1 plus 1, that is 6 here. So you see here also you do this. 1 square plus 2 square plus 1, 6. 1 square plus 1 square plus 1 square, plus 2 square. Here also you are getting 6. So ultimately this value comes out as 6h square by 8ma square. Okay, so 2 3s are 6, 2 4s are 8. This comes out as 3h square by 4ma square. So this the first excited state is this state has got, so the first excited state has got threefold degeneracy. Okay, threefold degeneracy. Although their wave functions or eigenfunctions are different, Okay, now the number of independent wave functions corresponding to the same value of energy is called degeneracy of the energy state. So what is the degeneracy of this state? 3. Okay, degeneracy of this state is 3. So in a one-dimensional box there is no degeneracy. In a one-dimensional box there is no degeneracy. Okay, so now let us write here that energy levels energy value, quantum number, and degree of degeneracy. Degree of degeneracy. Energy levels, energy value, quantum number, degree of degeneracy. So what energy levels is E11. This is what? This is the ground state. This is the ground state. What is the energy value? 3h square. I have done it. 3h square by 8 ms square. What are the quantum number? 111. No degeneracy. No degeneracy. Okay. Then E112, E211, and E121. Okay. The what is the energy value? Energy value is 6h square by 8 m a square. What are the quantum number? I have written only. And the energy is threefold. Degeneracy is threefold. Okay. 112, 121, and 211. Okay. Acha, then there is second excited state. Second excited state is what? E221, E212, E122. This is what? This is the second excited state. Okay. Acha, this is the first excited state. This is the second excited state. Second excited state, what is the energy? 9h square by 8 ma square. Here this is also threefold degeneracy. Okay. Acha, then you have the 1, 2, 3. Acha, then you have got the third excited state. The third excited state. Okay, what is the third excited state? Third excited state is E that is 221. Then you have got E311. Okay, E131. Then E113. Okay, and what is the energy of this? 11h square by 8 m a square. Okay, 311, 131, and 113. So 311, 131, and 113. So again, this is how much? Threefold degenerate. Again, this is threefold degenerate. Okay, this is the third excited state. Okay, then the fourth excited state. Fourth excited state. What is the fourth excited state? Fourth excited state actually hasn't got any degeneracy. E222. Okay, what is the energy here? Energy is 12h square by 8 ml square. Here you have no degeneracy. Here you have got no degeneracy. Okay. So in this way, this type of things are here.